solutions. See, the definition of solutions, then now you know that you have read from school. But anyway, let me write it again. It is a homogeneous mixture of two or generally we write most of the cases, even whether it is a teacher or student also they tell it is a homogeneous mixture of two or more substances. I will be little cautious about it. Homogeneous mixture of all substances may not be a solution. Why? Because if you have mixed sodium hydroxide in HCl and stir it to make it homogeneous, in the solution you will not find enough sodium hydroxide or HCl. It is going to form sodium chloride altogether a new compound. Please remember, solution is a mixture. We have mentioned mixture. So there is a difference between mixture and a chemical compound. So we'll write here now, it is a homogeneous mixture of two or more non-reactive substances. That is, when you add salt, common salt to water, water is saline. But if you evaporate water, again you get by the common salt. So please remember. So we should be cautious of mentioning this part. Non-reactive substances. Okay. The constituents of solutions are known as components. The larger component of a solution is called solvent. And the smaller component or components. If only one is there, we call it component, like saline water. Or you added sugar into water. But suppose you make ORS, in that case you put both common salt as well as sugar. Then it is this. Also. Solution containing two components are called binary solution, right? Ordinary.
Done, sir.
I told you after finishing, you should tell me. Otherwise, I'll write and erase it immediately, or I'll not teach. Now, how a solution will look like? Will it look like liquid, solid, or gaseous? So it is always being decided by solvent. The physical state of solution. It is physical state of solution depends upon the phase of solvent. Okay, remember like this. So I can give you an example. See, this example is very common. You have taken in a container water. To that you have added sugar. So what is this? Water is the solvent. So this is liquid. So solution will be all right. Acha. I don't know how many of you are present today. Please tell me your name one by one. I want to hear. Hello.
Sir Payal.
Then
Ishita.
Then
Sir Ashwa.
Madam,
Yam.
Sir Siddhi.
Sir Gitanjali.
Then
Agnik sir.
Then what is safety?
Naveen.
Safety is not there.
Sir present.
Okay.
Grace Kharmujai.
Good. Then Mr. Rahul. Hello. Rahul Bhattacharya is there. Okay, now see here. I think all of you either you know how to make handmade bread, we call roti, or in Khasi we call it atta. So what you do there? If you want to make roti, what do you take first? Give me some idea.
water and atta.
Will you put water in atta or atta in water?
Atta first.
Atta first and then water.
Gitanjali, you know how to make roti?
Sir, I know.
সত্যি সত্যি নো না এমনি আমার কইতেছস? হ্যাঁ?
Sir बनाएंगे तो जाने के तुम.
I tell your mother. You should know. This is after that what you do? We put here water. Do you put plenty of water there?
No, sir. Little.
See here. Is it not solid? We put less water. So in this case, water is the solvent, sugar is the solute. In when you go for making the dough or bread, in this case, atta is the solvent. Is it not? And water is the solute. So this is the solute. Now how the dough looks like? Is it liquid or solid?
Solid.
Yes. So here the solution that you get is physical state is solid. All right. Now, see, say this is a chamber. Here we have air. We know air is a mixture of gases. Which gas is maximum in air?
Hydrogen.
Hydrogen, if it is there, so it will catch fire, dear.
Nitrogen, sir.
Nitrogen. Nitrogen is 76%. The rest of the gases are less. Oxygen is 20%. 20 to 22%. Okay. So in this case, is it not solvent? Which is maximum? Nitrogen. So it is the solvent. Solvent should be always more. So how does the solvent here looks like? Is it not a gas? Nitrogen is gas or no? Nitrogen is a gas. So can you see air around you? Can you visualize?
No,
We
sir.
cannot see.
No,
Why?
sir.
Because solvent here is gas. So air is also gaseous. Okay, so what do you find here now? Here is gas. Please remember. So because of that physical state of solution, solid, liquid or gas depends upon the phase of the solvent. Here the phase of the solvent is liquid. Here the phase of the solvent is solid. And here the phase of the solvent is gas. Clear? So please remember. Now we'll go for the classification of solutions. So I'm not going to follow exactly whatever the book is given. We can classify solutions into two categories. One, based on physical state of solutes and solvents. B, based on the concentration of solutes. It is how much amount of solute is there? Is it less? Is it enough or more than enough? Okay, so let us go for this. Okay, see here you can find, you can simply by using mathematics, you need not know the thing, you can find out. We know there are three states of matter: solid, liquid, and gas. So solvents can be solid, liquid, or gas. Solutes also can be solid, liquid, and gas. So depending upon the solute and solvent, the name of the solution will be different. Okay. So here we will write solute, solvent, name, and examples. Okay, I'll write here now solute. to here I will write here. Here I will write liquid. Solvent I am not changing. Solvent. Here I will write gas. Okay. So, similarly, we have 3 more and 3 more, 9. Okay. So what will be the name? Name will be solid in solid. Okay. So can you give me an example? Solid in solid. No example.
So alcohol and water.
Solid in solid law. Alcohol is liquid. Water is also liquid.
So clay and mud.
Clay contains water. Hey, if you put baking powder in maida, what will happen? Is it not solid in solid? Okay, forget. I
Yes, sir.
give this type of example, so you cannot give in example. See here. Have you heard the name of this? Did you hear this name?
Yes, sir.
What you call it? You tell the name I've written.
Alloy.
Alloy. Have you seen any alloy? Any alloy you have not seen? In your house, alloys are not there.
Bronze.
Bronze is what?
Sir, a mixture of 2 or more metals.
Bronze contains more zinc. Zinc is the solvent. It contains copper and zinc. Then brass. Brass is what? Copper and zinc. Okay. So these are these. Then what is stainless steel? Stainless steel contains, what is the solvent? Iron. And what is the solute? Carbon, nickel, chromium. So these are the example of solid in solid solutions. Then liquid in solid. Solute is liquid, solvent is. So what should I write now here? Liquid in, just now I given you that dough that you make it with water. Okay. Have you heard the name of this one? Amalgam? Amalgam, you know? Amalgam is an alloy which contains metal and mercury. Mercury is liquid. We add very small amount of mercury. So it is solvent. And this is solute. Okay? Then we call it hydrated salt. Hydrated salt. Gitanjali, do you know any example of hydrated salt?
Sir, I'm thinking.
Thinking, acha, Dara. How long it will take to
Sir,
think?
sir,
Hmm.
global salt.
Tell me the example. What is the formula of global salt? Hmm?
I forgot.
Go for simple one. Copper sulfate, blue vitriol. Global salt is not sodium sulfate, magnesium sulfate. Magnesium sulfate, 7 molecules of water. This. Now, gas and salt. Okay. So we right now use gas in salt. All right. What should I write now here? Gas absorbed on solid in solid. There are many gases which are being absorbed. We pass the gas over hot metal, then gas get absorbed there, and after that, if you cool it, it will remain absorbed. Okay, this process is called occlusion. 4. Now we'll change this one. Okay, we'll write here. Solvent will go for liquid. So this again we'll repeat. Solid in liquid, then liquid in liquid, then gas in liquid. So this is known as solid in liquid. What is the example? Salt in water. This is the most common thing that we have done. Sugar in water. This is the example. Then liquid in liquid. Just now someone told me, I don't know the name. Liquid in liquid. So we can write here now. Ethyl alcohol in water. Now, third, gas in liquid. This example I will not give you. Tell me.
Sir, the most common is oxygen dissolved in water.
Yes, you are perfectly correct. But tell me a very popular one. Which is
Sir,
being
cool drinks. Carbonated drink.
yes, carbonated drink, for which you pay so much money and drink. Carbonated drink. What do people sometimes say? Soda water. Carbon dioxide is dissolved. in water. Because there you can see, moment open the bottle, you can see the gas is rushing out from the bottle. Okay, now we'll change all of them into gas. Same. Now, solid, then liquid, gas. 9 is gas. So we call it solid in gas. So what we can say now here? See, have you used naphthalene in your house?
Yes, sir.
What happens to the naphthalene after a few days? When you use these naphthalene balls in your house, what happens to the naphthalene after a few days? Does it remain same?
No, sir.
Then what happens?
It turns into gas.
It becomes smaller and smaller because they are the sublime. But again, they become solid in the air, but which you cannot see. Okay, so what you can say here? Naphthalene or camphor in air, or what? Dust particles in air. But these particles are not visible to us. So this is called liquid in gas. Okay. What do we call this one? We call it humidity. Or which is sometimes visible to us, we call it mist. And this is gas in gas. So we can write here mixture of oxygen and nitrogen, or what we can call it. We'll go for A we have done. We'll go for just give me 1 minute. I want to make a call. on concentration of solutes. Okay. So now this can be classified into three categories. Dilute solution. The solution which contain small amount of solute are called dilute solution. That you might have made also. You wanted to make tea, you have added less sugar. After drinking, then you find sugar is so less. So after that, what you do? You add some more. Okay. So what I can say now, or dilute solutions are those whose concentration can be increased. That is, you can add some. You can increase the amount of the solute there. So dilute solutions are those whose concentration can be increased. Okay, now we go for saturated. It is you have added less amount of the solute, then you stirred it. Then again, if you go on adding the solute and go on stirring, a time comes you find that solution cannot dissolve further amount of solute at that temperature. So that is a saturated solution. So what we can write? The solutions which cannot dissolve any further amount of solute at a specific temperature is called a saturated solution. Means what? Its concentration has become constant. That is, we can say saturated solutions are those whose concentrations are constant at that it is concentration is not going to decrease. I told you that it cannot dissolve any further amount of solute. So what did I do? I heated it. When I heat it, you'll find that some more substance will go into solution. And after that, if I bring it to room temperature, this excess amount of solute that you have dissolved to a saturated solution will precipitate, will come out in the form of crystals. So such solutions are called super saturated solution. Super saturated solution. See, suppose your mother has made a sugar syrup after boiling sugar in water. If whenever she brings it down, keep it, you find the sugar is separated from there. Okay. So what should I write down? Super saturated solutions are those whose concentration decreases. So here the concentration decreases. Why did I write can be increased? If I don't add, it will not increase. But in this case, it will decrease. Even if you don't do anything also, the excess amount of the solute which you added forcefully, it will precipitate. Solutions in which water is the solvent is known as aqueous solution. Okay. And solutions which do not have water as solvent, we call them as non-aqueous solution. Okay, your hand sanitizer is a non-aqueous solution. Your solvent is ethanol. Okay, so hand sanitizer is the non-aqueous solution. This is your solvent. And this is your solute. See here, in a glass of water, when you add salt or sugar, in a glass of water, you did not find any hole is there. Okay, that is all the molecules are attached to each other by intermolecular forces of attraction. So what you have here now? You have here now solvent, and this is having solute, interminded. They all molecules are separate, but they are staying with each other because of attraction. Okay. Now, when you have added this is a solvent, now this is a solution. Okay, you put this tube here. This one you put it here. This also. Now what do you have here? The solute molecules are going within the solvent molecules. Solute molecules are not entering solvent molecules. Solute molecules are going to solvent and occupying the space. See here. It was the solvent mode. You have no space. Little bit gap is there. So this is solvent and this is the solute. Solute. Okay, I'll just label it. So when you put them there, what will happen now? They'll go inside and display some display some solvent molecules are occupy that space. So it will be like this. So this is the solution. This is the solution. What happens now? Where solute molecules displaces some solvent molecules and occupy their space. So this is the one. This is the technique of making solution. Draw. You have to understand everything so that you don't have to read book. Science is not a method to by heart. Solvent interaction or attraction. How the solute molecules are being held? I told already written here. Solute, solute, interaction. Now a new interaction has developed. A new interaction. What is this? Solute, solvent, interaction. That is the new interaction that you find it develops in solution. So a solution involves three types of interactions. Solute-solute interactions, solvent-solvent interactions, and solute-solvent interactions. Okay. So a solution involves three types of interactions. One, solute interaction. Solvent interactions. C, solute solvent interactions. Okay, now we'll explain. Write it. See, if these molecules are very tightly packed, means what? They have very strong interactions, then only few molecules will break open from there, and it will go into solutions. Second, even if they break, if these molecules are very compact, then you'll find it will not allow this molecule to enter. Suppose you have taken two containers. In one container, suppose you have taken, say, in your kitchen, you have one container, you have kept atta, in another container, you kept muri. You'll find if you want to put your finger into that container containing atta, it is so compact, your finger will go, but it not going to dip. But if you put your hand inside the container containing muri, is so loose, entire hand will go inside. So it depends upon their nature. Not only that, even if they got dispersed, this also got dispersed, this also got dispersed. But after in the new association which is being formed, if they don't like each other, what will happen? The solubility will decrease. And if they like each other, the solubility is increased. Because of that, you will find the solubility of salt in water is less than that of the solubility of sugar in water. Sugar dissolves faster in water than salt. Okay, so what we can say? The solubility, I should write bigger. Solubility of a substance depends upon the solute solvent interaction. What does it mean? So they are already linked with each other. But if these new interactions, solute-solvent interactions are found to be stronger than the previous interactions, means solute-solute and solvent-solvent interactions, then the dissolution process will be very fast. Will be very, very fast. See, if you go to a place where you find it very comfortable, then you always like to go to that place. But if you go to a place which you find that you are all elderly people are there, with whom you are going to talk? You with them you can talk, auntie, how are you, uncle, how are you, this and that. And old people will always ask you, how's your result, this and that. This type of discussion you don't like. So next time if you are being asked to go, so you will simply say, I'll not. Okay. So what should I write now here? Thus, if the solute solvent interactions are Stronger means it is more comfortable. Stronger than their previous interactions, means before mix. So before mixing of what interaction they had? They had interactions or relationship with themselves. Means what? Solute, that is this, and solvent interactions. If the solute solvent interactions are stronger than their previous previous interactions, that is solute and solvent interactions, then the dissolution means going to solution. Dissolution process is fast. Okay. Second, if the solute solvent interactions are weaker than the previous solute and solvent interactions, then dissolution process is slower. From the thermodynamic point of view, see here, we have again taken the solvent. So this one supposed to break up like this. All should move away from each other. Why they should move away from each other? Then only in all these places the solute will come. Okay. So in this case, to disperse them, okay, solvent molecules getting dispersed. See, the process is endothermic. It is you to supply heat because you have to overcome the intermolecular Process of attraction. Process is endothermic. Let me write here. Delta H solvent. I will write here positive. Now same with the solute molecules. They have to open up. Okay, getting this first. To what? Then only they will go. When you put sugar into water, gradually, do you not find that sugar crystals are disappearing? This is happening. Water molecules are moving away from each other. Those places the solute molecules go. Solute molecules getting dispersed. The process is, you know the meaning of process of endothermic, means you have to supply heat. So what should I write now here? Delta H solute. Okay. Now they are making the solutions. Okay. Let me write like this. Hello. Good evening. আপনার ছেলেকে ক্লাস করতে নাকি আমার? So, sorry. See, these are the solvent molecules. Okay. So this is the. Suppose, say in future, you are going out of Shillong and staying in hostel. If you find your hostel mates are very good, then you feel very comfortable. But if they are not good, then you don't like to stay in hostel. So this is the one. So what you have now here? Whatever interactions you are having, that solute, solvent, interaction. Please remember, any interactions or relationship which is being formed, it always releases energy. Okay. So in that case, it is delta H solution. Okay. So please remember. No, sorry, not solution. We call it solvation. So therefore, what you will find? First you understand, then you write. Therefore, what do you find here? Delta H solution is sum of H. This is solvent. Plus delta H plus, see if I write here minus delta H solvation. Okay. Okay, right. Up. Finish it, right. Then we'll go. Man, man, lover, woman. Who is so happy? Next day, I'll also teach you by singing. Okay. I'll try to convert your chemistry thing into some song, but I don't know how to play guitar. I'll sing like that.
Done, sir.
Okay. Now see, let me rub it. So what did you find here? That these two are positive and this is negative. So if we write here, if delta H solvation is more than delta H solute plus delta H solvent, then see negative is more, then the solution will liberate heat. That is, it will be exothermic and will be highly spontaneous, means it will immediately go into solution. Highly spontaneous. Okay. Example. Dissolution of sodium hydroxide, potassium hydroxide, etc. If you dissolve sodium hydroxide and potassium hydroxide in water, you find water is boiling at room temperature and immediately goes into solution. Okay. If delta H solvation is less than delta H solute delta H solvent, then solution will absorb heat or endothermic. That is, this type of solution can be made by are generally non-spontaneous and are made by eating. These are endothermic and this is exothermic. So now you are going to apply Lee-Chatterley's principle. Do you remember Lee-Chatterley's principle? Oh, I did not teach you because those you are having exam and all this thing. Now see here. The process of making solution sorry the solubility of solutes in solvents depend upon Lee-Chatterley's principle. What will write? Increase of heat while making the solutions which are exothermic or spontaneous. I know that. Or exothermic. Increase of heat while making solutions which are exothermic in nature. Its solubility of solutes decreases. Second, increase of heat while making example. Increase of heat while making the solutions which are endothermic in nature. The solubility of solutes increases. Example, sodium chloride, sugar, etc. Right. I'll take 5 more minutes, then I'll finish. All right, finished.
Done.
Okay, now the question is, if they are non-spontaneous, if they do not like to go, they don't like the solvent, but still why are they soluble in water to certain extent? Why? See, here comes thermodynamics. Okay. Gitanjali,
Yes, sir.
আজকে থেকে বাহাতে রুটি বানাইবে হ্যাঁ
Okay, sir.
না দাঁড়া রুটি বানাই খবর দিয়ে আমি দিয়া খাই don't laugh at my doing, huh? See, my question is that this one, it doesn't like water. See, we know salt, we get it from where? Seawater. Only 2.3 gram of salt is soluble in 1 liter of water. 2.3 gram. That is, in such a large volume of water also, the solubility is so less. Why? Because sodium chloride don't like water. So once how do you get common salt? We evaporate. Moment you start evaporating, it's because they do not like water, they immediately precipitate. All right. Now see, then why it still go? You know why? Because the particles are so compact and they do not have any mobility. Everybody wants freedom. So it burst open. The cell wall breaks. Why? Because a greater freedom. Means what? It is how do you get that greater freedom? By or what would you say? Randomness. That you do whatever you like. And that what you call it? We call it entropy. See. Now let us come back to our class. Delta H is equal to minus T delta S. See, here it has no freedom. Here it is having freedom. See, so S1 is less, S2 is more. So this T into delta S is a positive one. But as because minus sign is there, the whole thing is what? Negative. So when T is large, T into delta S is a large negative L. Then what is delta H? Delta H is the amount of energy required to break. So this becomes more than this. Minus delta is a large quantity and T into delta minus becomes more than delta H. Hence, delta G becomes negative. And so it becomes spontaneous at higher and goes into anything which you don't like to do under normal condition. When the situation becomes extraordinary, he becomes more. You find you can do that one. By that way, this value becomes, this is your reluctancy and this is your compulsion. When the compulsion becomes more than reluctancy, then the job is done. This is the simple logic of thermodynamics in human life. Okay, bye.